Hello. The James Webb Space Telescope is a scientific instrument of great importance for astronomy, as it allows us to observe the universe in infrared wavelengths, which are invisible to our eyes. With this capability, the telescope can reveal phenomena and objects that were hidden or distorted by interstellar dust, such as the first stars and galaxies that formed after the Big Bang, the formation and evolution of galaxies, the origin of planetary systems and life, and the atmospheres of exoplanets. In a collaboration between NASA, the European Space Agency, and the Canadian Space Agency, and using the James Webb Space Telescope, scientists discovered the presence of carbon-rich molecules in the atmosphere of the exoplanet K2-18b. Methane and carbon dioxide are among these carbon-rich molecules. The discovery of the molecules is allowing scientists to better understand K2-18b. The planet has been the subject of various recent studies and is estimated to be a type of exoplanet known as a Hycean planet, a term used to determine a planet that could possess a hydrogen-rich atmosphere and a surface covered by water. Moreover, K2-18b orbits in the habitable zone of its host star, K2-18, which is the region of space around a star where conditions are suitable for the formation and existence of liquid water. Data from NASA's Hubble Space Telescope previously indicated the unique properties of the exoplanet's atmosphere, leading more research teams to investigate the exoplanet. Orbiting the cool dwarf star K2-18, in the constellation of Leo, K2-18b is located approximately 120 light-years from Earth, and these types of exoplanets that are between the size of Earth and Neptune are not found in our solar system. Therefore, they have not been studied as extensively as giant gaseous planets like Jupiter and Saturn. According to a member of the SARCAR team from Cardiff University, although this type of planet does not exist in our solar system, sub-Neptunes, slightly smaller than Neptune, are the most common type of planet known so far in the galaxy. The scientists obtained the most detailed spectrum of a sub-Neptune in the habitable zone to date, which allowed them to identify the molecules present in its atmosphere. Many astronomers debate and research the characteristics of the atmospheres of these sub-Neptune exoplanets. Some even believe that, if conditions are right, these planets and their atmospheres could possibly sustain life. According to one of the project's authors, Nico Matsudan, from the University of Cambridge, these findings highlight the importance of considering diverse habitable environments in the search for life elsewhere. Traditionally, the search for life on exoplanets has mainly focused on smaller rocky planets, but Hycean worlds are significantly more conducive to atmospheric observations. So, what makes K2-18b such a special place? The data from Webb on K2-18b show an abundance of methane and carbon dioxide in the exoplanet's atmosphere. Interestingly, there is a scarcity of ammonia, reinforcing the idea that K2-18b could possess an ocean of water beneath its hydrogen-rich atmosphere. Furthermore, observations from Webb suggested the existence of dimethyl sulfide, or DMS. On Earth, DMS is a molecule that can only be produced by living organisms. The vast majority of all DMS molecules in Earth's atmosphere are created by phytoplankton in marine environments. However, more observations and data are needed to confirm the presence of DMS in the atmosphere of K2-18b. According to Matsuda, in the next observations of James Webb, these will be some of the main data to be collected and analyzed. By examining the characteristics and resources of K2-18b, all conditions seem conducive to the existence of life on the planet. From being an exoplanet in the habitable zone, to the presence of carbon-based molecules and the possibility of a liquid ocean on its surface, K2-18b is a perfect candidate for a habitable exoplanet. However, there are some characteristics of K2-18b that may hinder the sustenance of life. One of these characteristics is the immense size of the planet. This immense size may indicate that its interior likely contains a large mantle of highly pressurized ice, similar to the internal structure of Neptune. Moreover, the ocean of K2-18b may be too hot to be liquid or to sustain life. However, obtaining spectral data from the atmosphere of K2-18b was no easy task. The exoplanet's parent star is very bright, meaning some of the Webb observation data could have been interferences from the light of K2-18, the star, rather than the planet. To collect spectral data, Webb observed K2-18 as the exoplanet crossed in front of the star, a phenomenon known as transit. When the planet passed in front of the star, Webb recorded a decrease in the star's brightness and collected data on the planet's atmosphere as it was illuminated by the star. These data were then sent to scientists who examined them and looked for signs representing certain molecules, like carbon dioxide. This method of using an exoplanet's transit to collect atmospheric data is widely used by scientists researching exoplanets. In fact, many scientists use this method of observing transits to discover exoplanets. K2-18b was discovered by NASA's K2 mission in 2015 through a transit. According to Madhusudan, this result was possible only due to the extended wavelength range and unprecedented sensitivities of Webb. For comparison, a transit observation with Webb provided accuracy comparable to 8 observations with Hubble, conducted over a few years and in a relatively narrow wavelength range. Scientists were able to extract atmospheric data from just 2 transits of K2-18b in front of its star, highlighting once again the true power and capabilities of the James Webb in exoplanet science. Webb is also scheduled to conduct additional observations of K2-18b in the coming weeks, which will provide the team with even more data to analyze and, hopefully, discover more molecules. James Webb truly has done a lot for astronomical science and already has some interesting things in its record. The telescope was launched on December 25, 2021, and took about 3 months to reach its final orbit at the Lagrange point, L2, 1.5 million kilometers from Earth. During this period, it underwent a complex process of unfolding and adjusting its components, like the main mirror, sun shield, and scientific instruments. The first images released by the telescope were stunning and show the universe as never seen before. Let's recall some of the most amazing images made by the James Webb Space Telescope. The Tarantula Nebula, a region where thousands of stars are born in the Large Magellanic Cloud, a neighboring galaxy to ours. The image shows the different temperatures and compositions of the stars and gas in various colors. To us lay people, the images made by the telescope are just a wow, how beautiful, a truly intriguing thing. But for scientists, it told much more about the nebula than they already knew. An example is the galaxies and the dozens of young stars that hide behind the immense dust clouds, which previous telescopes were unable to capture until now. The Eagle Nebula, or simply M16, is most famous for the so-called pillars of creation, which are gigantic columns of gas and dust that harbor new stars. In the new image from James Webb, scientists explain the pointed objects in orange tones that escape from the heap of gas and dust. These are the newly formed stars. According to NASA, the estimate is that they are only a few 100,000 years old. The red regions, with the color of lava, are ejections of material coming from stars still forming within the pillars. The Carina Nebula, another star-forming region, is where the so-called cosmic cliffs are observed, edges of a gaseous cavity sculpted by radiation and winds from young, hot stars. The cavernous area was sculpted in the nebula by intense ultraviolet radiation along with stellar winds from extremely massive and hot young stars. Another incredible image made by Webb, which ended up updating the photo previously made by Hubble, is of the Cartwheel Galaxy, whose ring shape, or as some say, a wheel, may have been the result of a collision millions of years ago with another galaxy. The ring formed was generated by the shock waves produced by the impact. But before that, the galaxy would have practically the same shape as our Milky Way. James Webb is still at the beginning of its functions, and NASA hopes that in the coming years, with updates and adjustments, the Space Telescope can still send the most desired information by astronomers around the world about possible lives in the universe beyond ours. Let's wait, right? Until next time.